Hello class 7, welcome to the chemistry class again. We will talk about air and we'll continue with air and atmosphere. Today we'll study the properties of oxygen. Okay, so the properties of oxygen. Natural properties of oxygen. Nature, oxygen is colorless, odorless and tasteless gas. It is sparingly soluble in water. Okay? Sparingly soluble in water means it is slightly soluble in water. Since it is slightly soluble in water, aquatic life is possible. Okay? So aquatic life means the life in the water, like fishes and plants. They use the dissolved oxygen for respiration. Density, it is as heavy as air, or maybe we can say it is slightly heavier than air. So it liquefies at minus 183 degrees Celsius and it solidifies at minus 218.4 degrees Celsius. Now we come to the chemical properties of water. Oxygen is neutral to litmus. It is neither acidic nor basic in nature. And combustibility, it itself does not burn. It helps other things to burn. It is non-combustible gas, but it supports combustion. Okay? Means it does not burn itself, but it helps other things to burn. As we know, nothing can burn without oxygen. Now, reactivity. Oxygen reacts with metals and non-metals to form oxides. For example, iron reacts in the presence of moisture and oxygen. Oxygen and moisture to form rust, that is iron oxide. Similarly, carbon reacts with oxygen. It burns in oxygen to form carbon dioxide, or if less amount of oxygen is present, then we get carbon monoxide. So, when we talk about the reaction of oxygen, we'll straight away go to a very important reaction of oxygen that is called, which takes place in the animals or maybe in the plants as well. It is called respiration. So respiration is a continuous process that takes place in living organisms all the time. It is a chemical process by which living organisms take in oxygen and use it to produce food. So we have already studied in biology that respiration takes place in plants as well as in animals. For the combustion, the respiration means reacting of oxygen that we breathe. Like for example, when we take in oxygen, we breathe oxygen, and that oxygen goes to different cells and where the food is already present. So this oxygen will react with the food, and then carbon dioxide and water vapor is formed, as well as a lot of energy. So energy is released. This process is called respiration. Okay. So carbon dioxide and water vapor are released as the products during the respiration. So here is the equation of respiration: C6H12O6. This is glucose. Reacts with the oxygen that we breathe, okay, to produce water plus carbon dioxide plus lot of energy. So carbon dioxide, glucose, the food that we have in the cells, react with oxygen that we breathe to form carbon dioxide, water and lot of energy. So this happens in this reaction takes place in plants as well as in animals. So the byproducts are, as I told you, that is carbon dioxide, water and lot of energy, which we use for various activities. Combustion. Combustion means burning, reacting with oxygen. Any substance burns in oxygen, that is called combustion. So combustion is a chemical reaction in which a substance such as a fuel reacts with oxygen to produce heat and light. So that is called combustion. Like for example, we use kerosene oil in kerosene stoves and all. Heat and light is produced as energy. So this is called combustion. So combustion is a chemical reaction in which substance or a fuel reacts with oxygen to produce heat as well as light. For example, charcoal burns in oxygen in the presence of air to produce carbon dioxide and heat. Like charcoal, that is, or coal, reacts with oxygen. It burns in oxygen to produce carbon dioxide and lot of energy, heat and light. Less of light and more of heat. So therefore, this is combustion. So similarly, magnesium burns in the presence of oxygen to produce an ash-like substance, white ash-like substance called magnesium oxide. So magnesium is a metal, a reactive metal. So magnesium burns in oxygen. Magnesium burns in oxygen to produce magnesium oxide, and a lot of heat and light is evolved. Okay? So, of course, these are not balanced equations. So magnesium plus oxygen produces magnesium oxide. So this is a combustion of magnesium. Magnesium burns with a dazzling white light to produce magnesium oxide, heat as well as light. So when wood is burnt in air, it forms carbon dioxide, water vapor, smoke as well as ashes. This is also another type of combustion. Okay? So a substance that burns in air or oxygen to give out heat and light is called a combustible substance. So any substance that burns in oxygen to produce heat and light are called, those substances are known as combustible substance. For example, wood, paper, coal, LPG, liquid petroleum gas, compressed natural gas, CNGs, petrol, kerosene, diesel, alcohol, ether. These are all butane. You must have heard about butane, the gas that we use in the cigarette lighters. This is butane. So it's a hydrocarbon. So it burns. So therefore, these substances are called combustible substance. Okay? So combustible substances that burn or catch fire very, very easily, they are highly inflammable. They are called inflammable substance. For example, alcohol, petrol, kerosene, diesel, benzene, butane. These are combustible substances. Butane, even a spark can burn the gas, isn't it? The LPG gas that we use at home, LPG gas, even a spark can burn the gas. So it is highly inflammable. So those substances which burns very, very easily, which catch fire very, very easily, are called combustible or inflammable substance. So conditions necessary for combustion. Now, first and foremost thing, oxygen is important. Okay, oxygen is needed. Nothing burns without oxygen or in the absence of oxygen. Remember that. So combustion takes place. For the combustion to take place, you need a combustible substance, obviously, and oxygen to support combustion, as nothing can burn in the absence of oxygen. And then you need to have heat. You must have heat to heat the combustible substance so that it reaches a particular temperature, then it will catch fire. So this temperature is known as ignition temperature. Okay, this is known as ignition temperature or kindling temperature, ignition temperature. Suppose you burn paper, you put it in the flame, in the candle flame, it right away does not catch fire. You have to, it takes a few seconds or maybe a fraction of a second. It needs some time for the paper to burn. Why? Because it needs, the flame will heat the paper, and the paper reaches a particular temperature, then it will catch fire. So that temperature is known as ignition temperature. So the lowest temperature to which a combustible substance must be heated so that it starts burning in the presence of air is called the ignition temperature. Even if a combustible substance is put in the gas jar of oxygen, it does not catch fire straight away until its temperature is raised to the ignition temperature. Different substances have different ignition temperatures. Inflammable substances such as petrol and alcohol have very low ignition temperature. That's why it catches fire very, very easily. You don't have to heat too much. So it can catch fire very, very easily because the ignition temperature of petrol, kerosene and all, it's very, very low. So the conditions necessary for combustion we'll talk about to take place are as follows. So what are the conditions for the ignition to take place? Combustion to take place. The presence of a combustible substance, obviously you need something to burn, so you need a combustible substance. Number two, you need oxygen or something that supports oxygen, combustion, that is oxygen. And the last one is, the third one is, it must reach the ignition temperature. So these are three things that is needed for something to burn, to catch fire. Number one, a combustible substance. Number two, air or oxygen. And number three, it must reach an ignition temperature for it to burn. So combustion will not take place in the absence of any one of the conditions. So if the supply of air to the burning candle is cut off by inverting a tumbler over it, the flame goes off. So you have a candle burning. Of course, we must have done the experiment earlier also. So we have a candle, burn it, and then as the candle burns, we cover it up with a beaker or a glass or whatever. What will happen? The flame gets extinguished. The flame will get extinguished. It will not burn. Why? Because all the oxygen inside the jar have been used up. No more supply of oxygen, therefore it will stop burning. A simple experiment that we have done in the classes earlier also. So similarly, if we throw the sand over some burning wood, the flame is put off because the candle stops, or the flame is put out because the supply of oxygen is cut off. Okay? Now we talk about the differences between respiration and combustion. So respiration, as we know, it takes place in the living organisms, where oxygen reacts with the food, and then carbon dioxide, water and energy is released. So combustion is just simple burning of substances in the presence of oxygen. So in both the cases, respiration and combustion, oxygen is required. Number two, carbon dioxide and water vapor is released. And then here also, in combustion also, carbon dioxide and water vapor are released. The next point, comparison between respiration and combustion is, respiration is a natural and it's a continuous process. So it takes place naturally. Okay. So combustion is mostly an artificial process, and it's not a very continuous process. Respiration is a very slow process, whereas combustion is a rapid process. It's a very, very fast process. It burns very, very fast. Whereas respiration, the oxidation of food in your cells, it is very, very slow process. Next point is, it takes place at a body temperature. Let's say in human beings it is 37 degrees Celsius. That's a normal body temperature. Whereas combustion takes place at the ignition temperature, which is normally it's quite high. Normally it's quite high. And the last point is, small amount of energy is released in the form of heat. Okay, in the form of heat. Very small amount of energy is released during respiration. Whereas in combustion, lot of heat in the presence, a lot of energy in the form of heat and light will be formed. So a large amount of energy is released in the form of heat and light. So with this, we come to the end of the chapter, but we have yet to continue with rusting. Before we close the chapter, we will talk about rusting. Now, rusting is also oxidation of a metal, that is iron. So iron but it's a very, very, very slow process. It takes place. It does not, it takes place in the presence of moisture. So when iron objects are exposed to air, its surface gets covered with a reddish brown powder that is called rust, and the process of formation of rust is called rusting, and it's a very, very slow process. A brown flaky substance will be formed all over the iron. So that is rust, and that is oxide of iron. So the conditions necessary for rusting is number one, the presence of air, oxygen obviously, and the presence of moisture or water. Then only rusting can take place, or iron will rust. Now let us talk about the let us compare the rusting and combustion. Okay. In both the cases, oxygen is needed, of course. Yeah. In rusting also, oxygen is needed, whereas in combustion, obviously, oxygen is needed. In rusting also, as well as in combustion, the products are the oxide. Like for when you burn carbon, you get carbon dioxide. Like when iron rusts, it is also iron oxide. So in both the cases, oxides are formed. The differences is, it is a slow process. Okay, rusting is extremely slow process, whereas combustion is a very rapid process. Another difference is, little heat is released, or almost no heat is released, whereas combustion, lot of heat is released. Moisture is necessary for rusting. Okay, moisture is necessary for rusting, whereas moisture is not necessary for combustion. Only air is necessary for combustion. So with this, actually we come to the end of the chapter, but we are yet to deal with the property preparation and the test of oxygen, which we will do it in the next class, because we had some issues with the projector today. So in the next class, I'll make sure that the projector is set, and then we will have some visual class. Okay? Thank you so much for watching. I hope you understood.